Today we are going to deal with respiratory physiology. In respiratory physiology, we will be dealing each session in different videos. In this video, we are dealing with lung volumes and lung capacities. To learn about lung volumes and lung capacities, we must be familiar with some numbers and a graph. So, there is a graph where we will be having quiet respiration. The respiration at rest is known as quiet respiration, right? So during quiet respiration, the amount of air that we inspire and we expire, then inspire, expire. So the amount of air that we inspire or expire is called as tidal volume. The amount of air that we breathe in one breath is known as tidal volume, and it is equal to 500 ml. It's equal to 500 ml. And sometimes we forcefully inspire. We forcefully inspire, right? So the extra air that we breathe in during a forceful inspiration is known as inspiratory reservoir. So now you say the extra air that we expire during a forceful expiration is known as expiratory reservoir. Now, however we expire, some amount of air will be there in the lungs. That volume of lung is known as residual volume. However we expire, this volume cannot be expired. It cannot be manipulated. It is known as residual volume. So there are four lung volumes. One is tidal volume, inspiratory reserve volume, expiratory reserve volume, and residual volume. Understood? Now we have to study, we have learned four lung volumes. Now we have to study about lung capacities. But before that, we must understand how much it is, right? So for easy calculations and not by hearting stuff, we don't remember a lot of things, right? So for easy learning and for making it very simple, I'll introduce you some numbers: 1.2, 2.2, 2.7 and 6. So up to here it is 6, it is 2.7, 2.2, 1.2. So then we can calculate, right, from 1.2, then 2.2 minus 1.2. It is 1. 2.2 minus 2.7 minus 2.2. It is 0.5, right? So we can calculate it. It is in liters, okay? That is why it is 0.5, what? 0.5 liter. That is 500 ml, okay? So it will be very easy to calculate then. If we understood how it is and what it is, it will be very easy to calculate if we know these four numbers. So it's all in four numbers actually. The numbers are in four numbers. The lung volumes are in 4. And now we are going to deal with lung capacities. That is also 4. 4 lung capacities. We can see the amount of air that we can inspire, maximum amount of air that we can inspire, how much it is. It is tidal volume. During quiet respiration we inspire, right? And during forceful inspiration also we inspire. So it's the addition of both, right? So it is tidal volume plus inspiratory reserve volume, which is the maximum amount of air that we can inspire. It is known as inspiratory capacity. What is lung capacities means? It is the addition of two or more lung volumes. Understood? So it is inspiratory capacity, and then how much air can we expire after a forceful inspiration? After a forceful inspiration, how much is the maximum amount of air that we can expire? It is from here we are starting, right? From here up to here. We cannot expire residual volume. That is what we discussed first. Residual volume cannot be manipulated during inspiration or expiration. So residual volume will be there in the lung, right? So this is known as vital capacity. Understood? The maximum amount of air that we can expire after a forceful inspiration. That is vital capacity. Inspiratory capacity, vital capacity. Now the total amount of air that the lung can have is known as total lung capacity. Total lung capacity. Now we have dealt with 3 capacities. One more capacity is left. What is it? It is very important. It is that after a normal expiration, this is inspiration, this is expiration. After a normal expiration, what is the amount of air that is left in the lung? It is known as functional residual capacity. Functional residual capacity. When we say left in the lung, how much is left inside the lung? Then we'll say residual, right? Here we said even after a forceful expiration, how much it is left in the lung, it is called a residual volume. Now, after a quiet expiration, how much air is left in the lung? It is called functional residual capacity. Understood? So it is addition of ERV plus RV. Inspiratory capacity is addition of IRV plus TV. Vital capacity is addition of IRV plus TV plus ERV. Total lung capacity is addition of whole 4 lung volumes. We understood all this. And so this point is very important. We will be discussing about this in lung and chest wall pressures, because this point is the point where the lung, we know the lung has a tendency to collapse, and the chest wall is balancing it by making the intrapleural pressure negative. This has a positive pressure. Anything that has a tendency to collapse is having a positive pressure, and anything which is pulling out from outside is making a negative pressure, so as to maintain this and not allowing the lung to collapse. So the chest wall is pushing outside or pulling outside so as to make this 0. And when it will be 0? At this point. There is a positive pressure. This positive pressure is turned to be 0 at this point. So it's balanced. The chest wall pressure balances the lungs tendency to collapse, making it the pressure inside lungs 0, and making the systemic pressure equal to atmospheric pressure. So that point is very important, and the volume of air that will be inside this lung at that point is equal to functional residual capacity. So that's very important. This is all about lung volumes and lung capacities. In next session, we'll be dealing with lung and chest wall pressures. Thank you.